The reactor burned for 3 days, but the most disturbing evidence did not come from the chimney. It came from medical files tracking children who drank radioactive milk, records many families would never know existed. By the end, you'll know what entered the food supply, why officials controlled the story, what later cancer investigations actually found, and the uncomfortable truth buried beneath Britain's reassuring public statements. October 10, 1957. At a secretive nuclear complex on England's Cumbrian coast, workers faced a reading that should have been impossible. Temperature was rising inside an air-cooled graphite reactor known as Pile Number 1. This was not a power station. It had been built to manufacture plutonium for Britain's atomic weapons program. The reactor's graphite core stored bursts of energy that periodically had to be released through controlled heating. Operators called this a Wigner release. But this time, parts of the core did not respond as expected. Workers heated it again. Then radiation monitors near the chimney climbed. Inside the pile, uranium fuel cartridges had ruptured. Fuel and graphite were burning in a reactor whose cooling system could feed the flames with enormous quantities of air. When an operator removed an inspection plug and looked inside, he saw fuel channels glowing red. Britain's weapons reactor was on fire. And outside the perimeter, families were waking, milking cows, preparing breakfast, with no idea that radioactive material was already moving above them. There was one barrier between the burning core and the countryside, filters mounted high inside the chimney stacks. They had been added late in construction after physicist John Cockcroft insisted that escaping particles needed to be trapped. Critics reportedly mocked them as unnecessary, calling them Cockcroft's folly. Now that folly was catching radioactive debris. But it could not catch everything. Iodine-131, cesium-137, polonium-210 and other radionuclides escaped into the atmosphere. The most immediate danger to nearby children was iodine-131. It behaves chemically like ordinary iodine, meaning the body concentrates it inside the thyroid. The route from reactor to child was brutally simple. The plumes settled on grass. Cows ate the grass. Iodine entered their milk. Children drank it, and their thyroids absorbed it. You might imagine an alarm spreading instantly through surrounding villages. It didn't. The fire was still being fought behind a wall of official secrecy, at a facility tied directly to national defense. Information moved cautiously, while contamination moved with the wind. Workers first tried forcing the reactor's cooling fans to maximum power. That risked making the fire worse. They pushed metal fuel cartridges from the rear of the pile, hoping to dislodge burning material. Some fell out. Others remained jammed inside. Carbon dioxide was pumped toward the flames, with little effect. By October 11, the core was burning fiercely enough that workers standing on top of the reactor could feel heat through the biological shielding. Then came the last option, water. Everyone understood the danger. Water striking overheated uranium and graphite could produce hydrogen, creating the possibility of an explosion. But the fire could no longer be allowed to breathe. Water hoses were connected. Cooling air was shut down. Men approached the reactor in protective equipment and opened the flow. Slowly, the temperature fell. By October 12, the flames were extinguished. The immediate crisis was over. No reactor explosion had torn across Cumbria. But here is the first contradiction: extinguishing the fire did not end the emergency. It merely moved the emergency somewhere officials could not see, into fields, kitchens and human bodies. Monitoring teams began testing vegetation, soil and milk. The milk readings forced action. Authorities prohibited the distribution of milk across an area of roughly 500 square kilometers. The boundary shifted as new measurements arrived, eventually affecting milk from hundreds of farms. For weeks, contaminated milk was collected and discarded. Some was poured into the ground or released into the sea under controlled arrangements. The intervention mattered. Later assessments concluded that removing local milk sharply reduced the thyroid dose children might otherwise have received. But imagine being a parent inside that zone. You are told not to use milk from your own farm. Officials say precautions are being taken. The reactor belongs to a weapons program you are not permitted to understand. Radiation is invisible, and your child may already have consumed it. You ask the obvious question, what happens now? There is no immediate answer. But before we examine what officials told those families, you need to understand something even stranger. The medical story would not be settled in 1957. It would take birth registers, cancer registries and more than 60 years of follow-up to determine what the children near the fire had actually experienced. Prime Minister Harold Macmillan's government commissioned an inquiry led by physicist William Penny. A public white paper appeared within a month. It explained the accident, praised the response and stated that the incident had caused no immediate harm to workers or the public. That statement was narrowly defensible. There were no confirmed acute radiation injuries among the surrounding population. Immediate protective measures had reduced exposure. The chimney filters had prevented a far larger release. But the published account was not the complete inquiry. The fuller technical report was withheld. Officials were deeply concerned about public confidence, Britain's nuclear program and sensitive cooperation with the United States. The country was pursuing an independent hydrogen bomb and negotiating nuclear relations with Washington. Anything suggesting British reactors were badly designed or poorly managed carried consequences far beyond Cumbria. So the public received information, but information shaped by strategic pressure. This is where the story is often simplified into two extremes: either nothing serious happened, or every later illness was knowingly concealed. The surviving evidence supports neither extreme. What it shows is more unsettling: officials could take genuine safety measures while still managing the truth. Radiation does not leave a signature that doctors can simply read decades later. A thyroid cancer cannot announce which atom caused it. A leukemia diagnosis cannot identify one chimney, one glass of milk or one October afternoon. To find a pattern, researchers need populations. They compare people exposed at certain ages with people born later. They link addresses, birth records and cancer registrations. They estimate contamination by location. Then they ask whether disease appears more often than chance would predict. For families, this creates an eerie transformation. A child drinking milk in 1957 becomes a line in a birth cohort. A diagnosis decades later becomes a registry match. A village becomes a statistical boundary. And those systems were imperfect. Later researchers found that historical name changes and incomplete early identifiers made some people difficult to link reliably across records. That was a data problem, not proof that individual files had been deliberately erased. Yet the effect on public trust was corrosive. When authorities begin with secrecy, every missing record feels intentional. Every uncertainty resembles a locked door. Every reassurance sounds rehearsed. Now comes the payoff. The strongest modern study did not uncover a concealed wave of thyroid cancer caused by the fire. Researchers assembled records from more than 56,000 people born in Cumbria between 1950 and 1958. The group young enough to have been exposed as children or before birth. They compared them with more than 137,000 people born from 1959 to 1980, after the accident. Birth locations were grouped by estimated iodine-131 contamination, then linked to cancer registrations extending through 2020. The result: no detectable increase in thyroid cancer attributable to iodine-131 from the Windscale fire. That conclusion does not mean the release was harmless. Measurements indicated that some children received thyroid doses exceeding 100 mg, while typical doses were lower. The milk ban prevented larger exposures. Radiation risk was real enough to justify emergency action and decades of investigation. It also does not erase a separate and troubling finding. Earlier studies identified elevated rates of childhood leukemia and non-Hodgkin lymphoma in the nearby village of Windscale during parts of the late 20th century. But official reviews concluded that radiation doses were too low to explain that cluster materially. Population mixing and infectious mechanisms became a leading explanation, though the history remains emotionally charged. So the suppressed truth was not a secret ledger proving mass illness. It was the gap between what authorities knew, what they feared, what they released, and what local families were left to imagine. There is another number attached to Windscale, and it must be handled carefully. Later radiological assessments estimated that the release could eventually cause roughly 100 additional fatal cancers across the wider exposed population, with some estimates higher depending on the model and radionuclides included. These are projected statistical deaths, not identified victims with death certificates marked Windscale. At low doses spread across large populations, researchers apply risk models to collective exposure. The result describes probability, not a list of specific people. That distinction matters because it is easy to exploit in both directions. Officials can say no individual death was proven and make the event sound harmless. Sensational accounts can present a modeled total as though investigators found 100 named victims and concealed every file. Neither is accurate. The honest conclusion is harder. The fire probably increased long-term cancer risk across Britain, but science cannot reliably identify which later cancers, if any, were caused by that release. For the families closest to the plant, uncertainty became the inheritance. The reactor fire was publicly acknowledged. Milk restrictions were publicly imposed. Multiple white papers followed. So Britain did not hide the existence of Windscale. What it hid was context. The complete technical inquiry remained restricted. Government discussions were shaped by diplomatic and military concerns. Even decades later, Parliament was still asking which Windscale papers remained closed under public records law. That distinction is crucial. A cover-up does not always mean pretending an event never happened. Sometimes it means narrowing the frame, publish the accident, soften institutional failures, emphasize immediate safety, withhold politically dangerous detail, then let time blur the rest. And time did blur it. Windscale was eventually absorbed into the larger Sellafield identity. The damaged reactor was sealed. The chimney filters became symbols of a disaster narrowly contained. But the families nearby remembered something different. They remembered milk being taken away. Officials measuring fields. Rumors moving faster than facts. Children later entering studies they had never asked to join. The radioactive plume dispersed within days. The distrust did not. Windscale's deepest lesson is not that every official statement was false. It is that technically accurate statements can still conceal the shape of reality. No immediate harm does not mean no exposure. No detectable increase does not mean no risk. No named victims does not mean no statistical cost. And publishing one report does not make a government transparent when the more complete account remains locked away. The medical records eventually gave Britain an answer more complicated than either reassurance or conspiracy. Children were exposed. Protective action reduced their dose. Long-term monitoring was justified. A major modern study found no detectable thyroid cancer increase from the fire. Nearby cancer clusters were real, but the evidence did not establish fallout as their cause. You are left with something history rarely offers, not a clean verdict, but a map of uncertainty shaped by secrecy. The reactor burned for 3 days. The argument over what it did to the people living around it burned for generations. If this broke your brain a little, subscribe. We drop one of these every week. Next, USS Cyclops vanished with 309 people and no distress call, a ship, a vanished crew and an ocean that returned no explanation.